that'd be really great. Anyway, so to get on with the evening, so this is the third of a series of events that we're hosting to engage with different parts of the supply chain. So contractors, builders, architects, consultants, as well as householders interested in retrofit. The next event in the series is actually this time next week with Harry Paticus. Actually, I'll just share my screen so I can show you what we've got going on. So next week we have Harry Paticus, who's doing the first step-by-step, so staged approach to Passive House. So that'll be a super interesting evening this time next week. Next week we've also got Eco Renovation for Builders, which is it's a course that Nick Parsons runs. He's done with us a few times before. It's had really great feedback, and it's going to be online this time for the first time, so that'll be interesting and exciting. And we're also working with Air Echo and Green Register to host a couple of ventilation trainings next year. So I'll pop all the links to those in the chat box. But yeah, I will. Oh, actually, I've got one more plug and then I'll stop with the plugs. If you are a consultant or architect or contractor or installer and you're interested in working with us further, it would be really great if you signed up. And this is particularly if you are UK based. So, you know, we're not really working, particularly if you're in Manchester. So yeah, do sign up. And if you've signed up on our form before, you don't need to do it again. So that'd be great. I've just put a load of information in the chat box about all these plugs. So that's all my announcements over. I'll stop sharing that. So we have a slightly different event tonight than what we'd hoped for. We had hoped to be on site at the sort of installation phase at Alan Williams, one of our early People Powered Retrofit clients, but he's giving us a wave. But there's been the inevitable delays. So instead we decided to focus this evening looking at Alan's plans for his internal wall installation, which is particularly interested in using sort of natural ecological products. One of those products we're looking at is Diathonite, which is, you know, there aren't that many suppliers and installers installing this kind of material. So we thought this might be a really good way to engage some of you who might be interested in this. So we're really, really pleased to be joined by 3 experts tonight at quite short notice. So yeah, thanks very much. So we've got Lois Hurst, who's a Passive House consultant. She's recently completed, I think I've written, completed, or maybe completing a self-build retrofit project and using Diathonite. I'm sure she'll tell us more about it soon. We've got Jesper Kirkman from Borderline, who are based up in Cumbria, who've been installing Diathonite for quite a few years. We've got loads of great experience to share with us. And then Bill Butcher from Green Building Store, who I will give you the ability to show yourself soon, Bill, who's also been working on a number of projects with Diathonite and is in the middle of a barn conversion. So we've got loads of really interesting speakers. It would be really great before we launch into it too far to just get a sense of who you are. So I'm about to launch a poll, if you don't mind engaging with it, just so we know who you are and kind of what you're here for and interested in. That will help our panelists. So if you could fill that out in the next 30 seconds. And I'm going to let Bill. Bill, you should be able to switch your video on now, by the way. Great. So we've got another 10 seconds and I'm going to end polling. So it looks like we've got quite a few architects and consultants in the room, a few others. No builders, unfortunately, a couple of homeowners, actually quite a few homeowners, and lots of people here to find a bit more about retrofit. Some people here specifically to find out about Diathonite, and some people here to find out about what People Powered Retrofit is. So hopefully we'll be able to meet your needs and yeah, but also feedback to us and evaluation. That would be great. So before we launch into our main speakers, it would be great to hear from Liam and Alan about People Powered Retrofit and particularly about Alan's project and how you're getting along. So I'll leave Liam to introduce People Powered Retrofit. Thank you very much.
All right, cool. Well, hello everyone, good evening. So yeah, we've in particular case of Alan. Also, Alan, do feel free to jump in whenever you feel like, or if I've said something you disagree with. This is we're probably 12 months into the process now, aren't we, from our first discussion?
Yeah, not quite. Yeah, but yeah, getting that.
Yeah, somewhere on the way to. So we've had a couple of site meetings. We got Florence, who is a sort of heating and ventilation consultant, involved to discuss plans for the wider retrofit. So yeah, a couple of interesting site visits, especially looking over the cellar insulation that you'd already done, which was actually, in the grand scheme of things, quite good, wasn't it?
Thank you.
And then so we worked through the design development state. Sorry, tangling over my words. It's been a long day. The design development phases. So as a background to the People Powered Retrofit approach, it tends to work based upon a project brief, ideally a home retrofit planner, which was previously named the My Home Energy Planner. I'm forgetting the old name now. And then we work through what are the best elements of the retrofit to be done, particularly taking into account the available budget for the work, just to make sure that it's sort of getting the best bang for your buck, so to speak, on that budget. So in this case, it was working through how we would do the wall insulation in particular, which has now ended up with external wall insulation to the gable and internal wall insulation to the front and rear, which is still up in the air. Well, the final design stages are happening due to illness on behalf of the architect, which it's just been the case of the year, hasn't it? One thing of COVID followed by this. So yeah, we've had some sort of chat about some back and forth about what the best insulation methods would be. There's been mentioned hempcrete, wood fibre, and diathonite. So that's been an interesting conversation, hasn't it, Alan?
Yeah, no, it has. I'll say a bit about that.
Yeah. All right. So yeah, we've moved through, and we're now onto, well, in some cases we're now onto the procurement phases of actually getting the work done. So we've got the ground floor insulation design all set up, and we're going to be having a sort of a training day where we work out how some of the elements of the air tightness are going to work when it's actually in situ. So that'll be with a Pavatex wood fibre insulation and 2 membranes. So we've got a windwash membrane and an air tightness membrane, and all the tapes going along. The bits where the joists pocket into the wall is, we have a few ideas as to how that's going to work. One of them definitely will, but we need to wait until we're on site and actually looking over it to figure out which one of those it will be. So the next stages now, Florence will be finalising the design for the ventilation and the air source heat pump, and just confirming that the correct size of air source heat pump, taking into account the thermal gains that we're going to get from the insulation. And then, fingers crossed, everything gets going in time. I'll be done for Christmas.
Which Christmas then?
I'm glad you asked that question. Yeah.
2021 Christmas.
Yeah. No, it'll be done by then. We'll all be home by Christmas. Yeah. Okay.
Right. Thanks, Liam.
Shall I go straight on then, Anika?
Go for it.
Right, just email me or something if this shuts me up or doesn't work. So right, so hopefully you can all see my slide there. Is that okay? So
yes, I can.
Yeah, great. Okay. So just a quick background from a customer point of view, if you like. So I didn't know until Anika invited me on this training that I was customer number 1 for the People Powered Retrofit. Not sure how much you know about that. I'll say a little bit in a minute. So it's a project from Carbon Co-op and Urbed in Manchester, the architects. So for me, People Powered Retrofit is the sort of hand-holding and advice and very client focused. So I sort of likened it this morning from, you know, if you said, well, I want to have an extension, and that's it, and then someone comes and builds an extension, and you don't really have much say in it. I've sort of got a feeling that's how retrofit can proceed a little bit, because it is out there a bit in terms of you know, different ideas and things like that. So the People Powered Retrofit for me has been crucial in informing me and training and all this sort of thing, and that advice and consultancy. So now we've got these new sort of standards to follow in terms of how retrofit gets done. So Liam is my retrofit coordinator, fantastic. And I started off as they were developing the project. So started off with a home energy assessment report to find out different options and to do all of the sort of measuring and estimates of heat loss and things like that. So that was done by the wonderful Gervais, who some of you will know. And these give you 3 different sort of options: a light, medium, and deep retrofit. Along with that, with joining Carbon Co-op, a cooperative, had lots of trainings and information from Anika and Jonathan Atkinson. And you know, one of the trainings was on hempcrete, when we destroyed Anika's house by doing some hempcreting, and that's what got me interested in hempcrete and then diathonite. As Liam said, we've got Florence as a mechanical designer to look at heating and ventilation, and she came up with a lovely, inspiring suggestion when she came round. And Steve from Urbed is doing the architect design. So all of the stuff, all of the principles that Carbon Co-op follow is what I'm doing. So, but the motivations are that the house has been cold. It's really cold and drafty, has been ever since. And we're now wanting to redecorate and replace the boiler, which is over 20 years old. So here it is. It's a typical 1910 semi, solid brick walls. That gable wall that you can see is as Liam said, that's the biggest heat loss, together with the drafts. And we're doing a whole house fabric first approach. So that's why we spent all this time planning and getting things sorted out. So external wall insulation on that gable wall, and then the internal wall insulation on the front and back came from really what Florence was suggesting. So when doing all this, I'm very concerned about maintaining the appearance of the house. We've got the street is a bunch of quite uniform houses, and I think you know, nice sort of architecture, nice features and all that sort of thing. So really want to maintain that. And then in terms of insulation, looking at what performance you've got, the environmental impact, and obviously the cost. So this is where, for the wall insulations, hempcrete came along because of the Carbon Co-op training, and then on top of that came diathonite. And I'm wondering if you could call it corkcrete instead. So here's the underfloor installation. You can't really see that very well, but I did that 20 years ago. So I've been interested in doing this for a long time, but was really nervous about blocking all the ventilation, all the air gaps and all this sort of thing, because of rotting the floorboards, basically. So I put insulation in, and very kindly Liam says that I did quite a good job, but there's loads of drafts, so it's probably not, loads of gaps, so it's probably not that effective really. But we'll hopefully be able to use that insulation in the loft. So I started off after the home energy assessment, probably wanting to do a medium scenario, and that's the bits on the left of the screen there. And when Florence came along, it turned probably now a bit deeper. And the thing there that Florence suggested, because we want to replace the boiler, and the medium scenario said, get a condensing boiler. You know, the one at the moment is just a standard, standard basic boiler. So get a condensing modern boiler. But she said, well, if you go a little bit further in terms of your insulation, you'll be in the realms of being able to get an air source heat pump. So why don't you go electric? And that's fantastic. I thought that's a really good sort of aim. So we've added some bits, especially the internal wall insulation that wasn't going to do. A full house mechanical ventilation system, and then upgrading the central heating. So those are the sort of extra bits that have come out from the consultations with Liam and Florence recently. I was probably always going to go for some window replacement, the doors, the underfloor insulation, doing it properly, upgrading the loft insulation as well, as the boiler, as I said, and getting a new hot water tank. We've also got some solar panels come along already, actually. So that's the sort of thing. I've moved slightly as we've gone through the project the last few months to go for the go electric, essentially. So with the underfloor insulation, let's just show you a bit of what the current situation is. That picture's a view underneath the floor, standing in the cellar. Hopefully you can just about see that, the joist and then the floorboards above. So it's absolutely freezing in the rooms above that, because you've basically got gaps in the floorboards and a direct draft from outside. But that involved taking down the ceiling, the lath and plaster ceilings. That created a right mess. But, you know, this is crucial in terms of getting the architect design to make sure that we don't muck up the all of the things that you need to worry about in terms of condensation and dampness in that timber. And hopefully then, with the training from Liam, I'll be able to do that myself. For the other bits that I mentioned earlier, looking to start procuring those. So the last picture, just to show you where we're at, that's the back of the house, southwest facing. That's our new solar panels on top. So that was done via the Greater Manchester Combined Authorities have these sort of bulk buying schemes for residents, where they can get not just a good deal, but they do all the sort of hard work in terms of finding a supplier and sort of getting someone who's going to be decent. So this was called the Solar Together scheme. I think it operates in other local authorities as well. It was done by EEC from Southport. Did a really good job, really pleased with that. So it's a 4 kilowatt peak output. Take the H out of that. And they've got nice, at the moment we've got a diverter, so it puts all of the excess generation into the hot water tank. So that will hopefully, in the end of the day, power the air source heat pump. So I'll stop there, go back to Zoom, and that gives you a bit of the background. But the key at the moment is working out what the external and internal wall insulation is going to be. I'm really interested to find about people's experience of diathonite, because you know, the characteristics of that being carbon neutral almost, in terms of its production and so on, the way you can spray it on is really sort of appealing. Okay, so Annika, that's me done.
Great, thank you, Alan. That's great, and you're really great at keeping on time as well. So yeah, next we have Lois, who did a lot of thinking about different kinds of materials to use, and yeah, really grateful to have her sort of feed in on. So you're going to do a bit of a product selection and analysis of looking at the different kinds of materials and sort of why you decided to go with Diathonite. So yeah, take it away, Lois. Thanks. And also I'll give you a little reminder if you're going a bit over time, if you don't mind, on the chat box.
Yeah, that'd be helpful. Thank you. Okay, so can you see my screen? Not yet. Now, can you see my screen?
Yeah.
Yeah, okay. Yeah. So hi everyone, and yeah, thanks for having me this evening. So I'm Lois, and I'm a self-build retrofitter. That's kind of my main reason for being here today. I'm also a PhD student doing my PhD on low energy retrofit and life cycle analysis at Heriot-Watt University. I'm an environmental scientist by training, and I've recently become a certified passive house consultant. And my session this evening is to look at my product evaluation for my internal wall insulation. So the context here is my house. This is some way into our retrofit. It's 6 years and counting. This was taken, I think, probably at the start of this year-ish. And just in the plan view in the corner here, you can see we've chosen insulation strategy for the rear and the gable walls, but we wanted to do internal insulation on the front walls for exactly the same reasons that Alan said. It's preservation of the aesthetic of the building. Now this happens to be a south-facing wall. We've got the solid rubble sandstone walls with original lime and ash mortar in the middle. They've been cement pointed on the outside. The property dates from around the 1890s, so it's quite old. There's no mechanical damp-proof course. Now on this front wall, we're fortunate insofar as it's actually elevated, the floor level is elevated about more than ½ meter above the ground level outside. So it means that we don't have flowing water or moisture anywhere too close to the footing of the wall on the interior. And we also understand that there was previously some kind of a drainage system retrofitted beneath the building during a renovation that it underwent in the 2000s. We're not quite sure what that is, because we've decided that taking up the concrete floor is just a silly idea. So we're just going to leave that as it is. But importantly, there's no evidence of damp on our front south-facing wall. So that's reassuring and one less thing to worry about. But it is a cold building, so we wanted to improve it. And the objectives of the internal wall insulation, as probably for most people, was to improve the thermal performance, whilst also mitigating any moisture risks. So we wanted to reduce heat loss, and we wanted to improve comfort. But the question there is, how much do we want to improve that thermal performance? And in terms of mitigating moisture risks, obviously we've got external sources of moisture, the weather, and so on. But also we've got sources of condensation of moisture inside the building, which can cause condensation in the building fabric. And we wanted to elevate the surface temperature of the internal walls so that we didn't get condensation forming on those surfaces. And typically we look to surface temperatures of higher than 13 degrees to mitigate mold, and 17 degrees for comfort. So that was kind of where we were aiming for. So what are our options? Firstly, when I first began thinking about this, like I said, it was 6 years since, and I knew a lot less than I know now. And we marched on down this road of thinking, oh, well, let's pop in some sheep's wool insulation. On the front wall, we'll build a wooden stud-work frame, pop in some sheep's wool and some plasterboard, and Bob's your uncle. And later it came to my attention that there were other alternative options with perhaps these wet lime plasters. We did almanar about these different options. I've learned since that the stud work with the insulation bats can be quite risky in terms of moisture, where if we've got pockets of air behind the insulation and against the wall, we can end up with little pockets of condensation forming. So in that case, you might want to introduce a vented cavity in that position. But in practice, this is incredibly difficult in terms of the constrained space inside, but also because, as I mentioned, we're doing the external wall insulation approach on the gables and the internal wall insulation on the front. The marriage of those junctions became really, really challenging with this internal lining approach. So we ruled out the stud work with insulation bats. And then we looked more closely at these different wet plaster options. One of which was Eden Hot Lime's hemp lime plaster. And we actually eliminated that early on as well, because the thermal performance was not high enough for what we were trying to achieve in terms of thermal conductivity. I will say we did use, we are continuing to use Eden Hot Lime for all of our lime, plaster, mortar and pointing requirements. So they've not been denied of all of our custom. But yeah, Eden Hot Lime are out in terms of the hemp plaster product. So I'm very much a numbers woman, and I love nothing more than a quantitative analysis. So I started out with my options appraisal of the remaining products, and I evaluated the options of applying 50 millimeters of any one of those products. Now it's important to remember that if we are trying to keep our insulation thickness to a minimum, we want to see smaller values for thermal conductivity. So that's these numbers in the first column, and also smaller values for U values, but we want to see higher values for thermal resistance. Now, I hope I'm not going too much into jargon for people here. If you're not familiar with these terms, then please bear with me. It's not the only thing I talk about. But I think for people who are familiar with these, it's quite a useful analysis. Of course, thermal resistance and U value both correspond to product thickness. Now, in terms of introducing cost into that analysis, I found it most useful to compare the cost per unit R value, which I've displayed in this column, because it normalizes the product application rate and its performance across the different materials that you're looking at. So to me, the pounds per unit R value was where I was looking for my best results. So you would look at these numbers and you can see that the lowest price per unit R value is the product by Bauer, which I don't think it's a cork and lime product, actually. It's possibly with perlite, I think. And this has the lowest pounds per unit R value. But when I looked more closely at the application rate to achieve equivalent U values, it ended up that we'd need to install nearly twice the thickness of Bauer Light than we would to install the Diathonite Thermactive. And so on that basis, it would have meant more product being moved around and a longer installation time, and that would have meant higher labor costs. So we chatted with Jasper at Borderline, who is going to be speaking shortly, about the Thermactive product, and he reassured us that we could install just 2 coats of Thermactive and it was only going to take them 3 days to do the whole house, or at least all of the bits we had looked at. So Thermactive won out on that basis. Now I've included these other rows at the bottom. So Eden Hot Lime, like I said, we did roll them out early on. We would have needed 200 millimeters of the Eden hemp material to achieve the same thermal performance as we got with the Diathonite Thermactive. And we felt that the time it would take to install that level of thickness was going to be just really, it would just slow everything down, and it would be such a disruptive process. And bear in mind, we're living in the house at the same time, that we felt that it was better to just get it done and dusted. Now, for your information for this session, Anika had said that Alan was interested in hempcrete, and I wasn't sure exactly which product, but I found a source that showed conductivities range from 0.05 to 0.02 watts per meter Kelvin, and the resulting U values with these conductivities are quite a lot higher, along with the hemp, the Eden hemp product. These are all much higher than the 3 products that I evaluated more thoroughly. So I don't have cost data for those, I'm afraid, but yeah, for me, the thermal performance was quite important. So that's why I was looking at these ones. So there we go. That was the winner, was Diathonite Thermactive, based on cost and performance and installation time. So that's all great, but what about, you know, how well is this product actually going to perform, and what are the moisture risks that we're introducing by using it? I decided that I would do a surface temperature analysis using Therm, which is a freely available online two-dimensional heat flow model. I should caveat actually that if you want to do a thorough and robust moisture analysis, you should be looking to use, you should be looking to probably employ the services of a consultant that is fully trained in WFI or one of the other moisture models. They should always be considered for high risk interventions. But in the case of our front wall, like I said, we're south facing, we're well above groundwater, there's no existing evidence of damp, and we're not applying a very thick layer of insulation, and we felt that it was adequate to just do this surface temperature analysis. So what I've done here, you can see in my graph, I've evaluated various product thicknesses. So this is just using Diathonite Thermactive. I've evaluated thicknesses through 0 to 100 millimeters. And I've looked at this on the basis of an external temperature of 0 degrees and internal temperatures of 17, which we think is probably our usual operating temperature, and also 20 degrees, which is the temperature that you model for passive house. And it's quickly apparent that without any insulation at all, in both cases, the surface temperature of the internal wall is below 13 degrees. So in those circumstances, we've got a red flag saying, look, we might well have mold growing on the walls. And if not on the walls, on the furniture that you've put against the walls. So that's not very desirable. But in the first 10 millimeters that we apply, we can already see that the surface temperature is increased quite dramatically. And in both cases, we are now above the 13 degree mold risk temperature. Now, when we go between 40 millimeters application and 100 millimeters application, we're starting to see a diminished return for our application. So we would conclude from this that there's a sort of sweet spot in terms of surface temperature between 40 and 100 millimeters, and probably we're not gaining much for that extra product that we're buying, the extra cost of labor, etc. So again, it enabled me to confirm and take peace of mind that 50 millimeters was a reasonable application thickness for our project. There are some limitations with this method insofar as it doesn't account for corners or thermal bridges, and we do need to be mindful of those because it's usual that it would be colder on the surfaces of corners and thermal bridges. But in terms of practical things that we could do to further reduce the moisture risk, we decided that we would remove the cement pointing that I mentioned from the internal and the outside walls. Now we've done the internal walls because we've already put the diathonite on, but we haven't yet done the outside walls, and that's on our to-do list, but probably not anytime very soon. So I'm just going to fly through some things on my installation experience. I'm not quite sure how I'm doing for time, so hopefully, have I gone over?
Yeah, you're almost over, but it would be
Okay,
really great to hear.
I'll just whiz through these pictures because
mine's going to be shorter anyway, so you go ahead, Lois.
Okay. I'll whiz through these. We did the installation in April 2018, like I said, with border lime. And then we coated the diathonite with lime plaster rather than the Argosem proprietary product from Diasen. We did that in July 2019. These were the substrates that we were applying to. So it was the solid stone walls, like I mentioned, and also we returned the insulation back down the gable walls a little way. and some of those walls were shiny brick. Is this bringing back bad memories, Jasper?
Just the shiny brick side.
So you can see around this window, we've removed the cement pointing and dubbed out in lime. This is Jasper making an absolute terrible mess of that carpet, but actually it's come up really nice since then.
Good.
It is a incredibly messy job, so don't be under any illusions that this is a quick and clean activity.
And don't live in the house at the same time.
No, I'm going to come to that actually. This was applying the spatter coat onto the shiny bricks, because the shiny bricks were not very grippy. We have actually since had some minor lifting of the diathonite off the shiny bricks in some places, but I think that was where the spatter coat was not applied quite as thoroughly as it was in the majority of it. Like I said, we also did have to move out of the house when it was being installed. It was such a damp and humid space for such a long time. We actually spent 2 weeks out of the house initially, and then we were away for a fortnight on holiday, during which time all the windows were shut. And when we came home, we were horrified to find that there was some mold growing on the surface of the diathonite. And of course we were thinking, oh, well, this shouldn't have happened because it's diathonite, it's coated in lime, you know, it shouldn't be growing any mold. But we were able to eliminate any further mold growth by getting the windows open, getting a dehumidifier running, and we sealed up over the diathonite as soon as possible afterwards, like I said, with our lime plaster, and we've not experienced any further mold problems. Excuse me, this was just the installation of the lime plaster over the top, which this was a busy weekend with friends and family roped in from all corners of the country. And this is a quick shot of some of the dried and finished walls. I took these pictures today, so you can get an impression of how far we've still got to go in terms of finishing the project. But we really love the finish of the walls, and you know, these soft curved window reveals. It's a beautiful product, and it's really made a big improvement to our comfort through last winter. Sadly, I don't have any quantitative data, but yeah, we've been really pleased with it. So that's all from me. So thank you very much.
Great, thanks, Lois. That was super interesting and really nice to see the pictures through the project. I'm sure lots of people have questions. So Jasper, you're next, if you don't mind giving us a bit of your insight.
I will. I mean, this is ad hoc. I've come in late from work, and it won't be as polished as Lois's. No pictures. So I've just written down some bullet points, really. So how did we find out about it? Well, we're in the process of doing a barn conversion for ourselves. Having built a few houses previous, I hadn't ever done a barn conversion, always built from the ground up. Didn't even think about the insulation, just a bit like Lois said, just automatically assumed it would be studded out and some sort of insulation put between the studs. And then the architect, great architects in Penrith in Cumbria, who probably one of the first architects to start using diathonite, had specified diathonite, did a bit of investigation, found out that this supplier was just down the road from where we live, had a chat with them, and we're already involved in lime work, so more traditional lime plastering and pointing and flooring. So we spoke to them and they said, well, the only installer we know of is down, I think it's Northampton area, perhaps. So we just thought, well, actually, it might be a good idea for us to get involved in this. It's lime. Everything we do is lime-based. And I ended up going across to Italy, to the factory, for a 2-day course, thinking that I would come back an expert. And I came back really appreciating Italy, but didn't really know much more about diathonite in terms of installation. The next step for us really was to buy a machine. Now, the installer down in Northampton area had a wet mix machine. quite a large machine and quite expensive. We decided to go for the PFT G4, which is a German machine, dry powder in one end and a lovely messy mix coming out the other end. Bit more flexible in terms of the size of the machine. So we ended up going down to see Les Lord at PFT Northern, who I know Bill's had some dealings with. Les wasn't the most enthusiastic about pairing up the Diathonite with his machine. So the G4s are perhaps used for more Parex, more modern mixtures. Having said that, Diathon do recommend the G4 machine, but I'm not sure if Les had great experience with it, trying to get it to work. And I have to say that our first probably at least 12 months of jobs was extremely painful, getting the product and the machine tuned together. But we really love the G4 machine. Good old German engineering. It's almost indestructible, and we have tried many times to break it. So as I say, our first few jobs, quite painful, getting the mixtures right, understanding the background, certainly when you come to different thicknesses, how to apply it, how many people to have on the job, because it's an extremely quick process once the machine gets going, as Lois knows. So it's taken us quite a long time to get a real good grip on running the machine and the different types of Dyson products. But every single job is different, and it depends on the background. I mean, what Lois didn't show you is we've sprayed on top of some girders at Lois's, some wood, some shiny bricks, some traditional stonework. It really does stick to most things. And as Lois said, very rarely do you get any peeling away. And you do have to do a spatter coat on anything that's slightly shiny. I think probably in retrospect, Lois, perhaps we would prime the bricks maybe next time if we did something like that again on such a big area. In terms of thicknesses, we have sprayed everything from around about 10 millimeters up to 100. Tend to spray in thicknesses of around about 20 mil. You have to really be careful with the machine and the thicknesses. Once you go above 20 mil, you get sagging. You've got to be really careful with your water flows. I was going to touch on it, but Lois did a better job. So for the evolution, I think once you get above 70, 80 mil, the cost benefit probably drops off in terms of insulation. Thermactive is better. So that kind of probably drops off at a less thickness because you get a better insulation. In terms of the jobs that we've done everything from inside to outside, inside and outside, inside by itself, outside by itself. And it just really depends. Sometimes it's aesthetics, as Lois mentioned. Sometimes it's where what sort of insulation you can put on what sort of substrate. We've just finished a modern retrofit of a farmhouse where they decided to, not our choice and not part of our job, but decided to stud out the inside with and use a sheep's wool type insulation there. But the outside we've sprayed 70 mil of Diathonite. So the outside looks absolutely brilliant. I'm not sure what will happen over time on the inside with the stud work that they've put in. An Ecological, who supply the product, we did some demonstrations with them a couple of years ago, and they did a really good video of where they took away some stud work that had some solid insulation put on it, and there was a lot of moisture behind there and mold and blackness. So we have spoken to a lot of builders about this. I think people can be scared of these sort of products, so they go with what they know, sometimes in terms of cost. So initially it might seem cheaper to throw some stud work up and throw some traditional Celotex or whatever you want in. we have spoken to a couple of builders who have then had to go back, possibly a few years later, because of issues, and they said they wish they'd spent a little bit more up front, and it would have just lasted. We have used Diathonite as a floor screed as well, because obviously with the pump, the installation is extremely quick. The only limitation that we've had with that is, and this was a recommendation from Ecological, is you can't use it with underfloor heating. It can't handle the expansion with that sort of installation. But as I say, we've pumped Diathonite into a number of floors as a screed. So it's a good insulator for that, and it's quite a quick installation. We've been probably installing for about 3 years, maybe slightly more now. And we have come across some disadvantages or things to consider. What we have found is that the drying times are extremely temperature dependent with Diathonite. And we've had some installations where we've had to leave them well over a month before we could put the top coat on safely. We have used dehumidifiers, Lois, on a number of jobs just to speed that up. So one thing I think to think about, and one thing we say to customers, and we're not the product experts, but what we tend to say to people is, just bear in mind this is a hydraulic lime, not a non-hydraulic lime. So Eden Hotline mortar tends to deliver or specify non-hydraulic. And hydraulic limes tend to be slightly harder, but slightly less breathable. So what we tend to say to customers is do your homework. If insulation is your main driver, then we would 100% back Diathonite. If you have a property that's perhaps a lot wetter or more moisture prone, then an insulation is not your main driver, then we would say to customers, consider a non-hydraulic lime. Now we've only ever had one customer go down that route, and we've not had any problems with Diathonite. But it's something to consider in terms of what type of lime you're using, hydraulic or non-hydraulic. In terms of applications and quantities,
do you mind
speed,
just quickly explaining the difference between hydraulic and non-hydraulic for those that don't understand?
Yeah, so I don't know whether Lois knows it better. So the way I describe it is hydraulic lime sets with water, hence its name. Non-hydraulic tends to carbonize, so it sets in air. There's three main types, it's probably the wrong word, of hydraulic lime. So what's the word I can use? Lois, help me out here. Three strengths, I suppose, is one way to think about it. So there's 2, 3.5, and 5. If you speak to people who are really into non-hydraulic lime, what they will say to you is when you get to NHL 5, and if you start going above that, you get very close to cement. So that sort of hardness. And if you were to, for example, point a bridge that's got a lot of water around it, you probably go for an NHL 5 mix, which is quite hard, can handle that sort of thing. You wouldn't go for a non-hydraulic mix. So traditional houses and barns were mostly built with non-hydraulic lime mortar. You can make them a hydraulic lime by adding pozzolans, and some people did add ash to it to help it set. So they're the kind of differences, and like with everything, it's horses for courses, so it's not a one size fits all. It depends on the project, it depends on the customer, it depends on the background, what you're putting it on for. So you've kind of got to understand all the different types. In terms of quantities and application, with the machine we've got, I think Bill's got the same machine. We could probably, the base coats of Diathonite, we could probably spray, depends how enthusiastic you are on the day, but 250 square meters in a day on the base coats. When you get to the top coats, obviously you want to be troweling it to get it to a flatter finish ready for the top coats. So we probably wouldn't do much more than 100 square meters in a day for that. One other thing to consider when you are hand applying, well, if you decide to hand apply it, and some people do, one thing to consider and look into is that when you do hand apply every coat, you tend to squash the air out of it, and the air is part of its insulation properties. But also, if you are aiming for a particular thickness for some reason, you've got to think that if you, with the machine, you apply 20 mil and leave it, apart from the top coat, if you're hand applying with a trowel, you will probably struggle to get a 20 mil thickness in one go with a trowel. So there's and what we've found as well is to get the same thickness, you're using twice the quantity of material as well. So we would always, I think ecological kind of say anything you can hand apply up to 50 square meters. We've done jobs where we've done 10 or 15 square meters, and it's just worked out. When you get to know the machine and you can set it up quickly, you know, you can be up and spraying in 5 or 10 minutes, and it's a better job. You maintain the insulation properties. So just consider that, you know, some builders who haven't got spray machines, you know, we've had one builder put it through a cement mixer to mix it up and put it by hand, you know, so, which is fine, but it depends what you're after. In terms of workload as a contractor, we're probably 50% diathonite, 50% other types of alignment installations, which is good for us. So it depends on the area where you are. I think there's some areas, probably down southern England, where there's probably less. There's not a lot of installers in England anyway, but there's probably greater workload down there for a contractor just to concentrate on diathonite. So in terms for us, we're more than happy with 50% of our time being diathonite and 50% being, you know, more traditional limes. That's basically our story, really. Ecological, the suppliers, a great company. They've got two brilliant engineers, Finton and Ilias. They know the product well. They've learned a lot from us because they've come out to a lot of our jobs halfway through and at the end. But yeah, great company, great product.
Great, thank you, Jasper.
That's me.
Thanks. And so our final speaker tonight is Bill from Green Building Store. So you've got about 10 minutes, Bill. Great, and also you're muted at the moment.
That's better. Hello, everybody. Hello, Lewis. Hello, Jasper. Thank you for all the help you've given us. And Liam, of course. I'm just going to try and share my screen here. Is that up and running? Can you see that?
We can see the back part of the presentation, so if you just press present, it should work.
If I press...
yes, it's brilliant. It's working.
That's it. Okay, right. Okay, goodness me, I could talk all week, not just for 10 minutes here. So I'm just going to talk about our experience with diathonite. We've got experience with other methods beforehand, obviously. We've been at this longer than I'd like to think, really, one way or the other. And we've done a lot in my 50 years in the building industry. I've done a lot of bad work when I think back on it. Kingspan, dot and dab on solid walls was what we were doing 20 years ago without really realizing what we were up to. Anyway, we came to Diathonite. My business partner, Chris, introduced me to this maybe 5 years ago. So this was our first project. Now, remember, we're up on top of the Pennines here, west of Huddersfield, above Holmfirth, and both these projects are rubble-filled stone walls, 450 thick with through stones, and we're in a high exposure position. So we also use WUFI, capital WUFI, which is a software program to actually model the walls to see how the moisture will behave within the walls over time. And we've also, in our jobs, luckily worked with Leeds Beckett's University and the ACB, and have been putting moisture sensors in the walls to actually see how they perform and whether it correlates with what Woofy's telling us. So anyway, this first job here is the Meltham barn at Lower Royds. This was probably 2015, these pictures were taken. So it was a barn, if you see here, I don't know if I've got a virgin barn, if you like, and then a 1950s farmhouse. And then we built a new extension on the end here. So it was brilliant in the sense that we could start from scratch, absolute scratch. So we come from a passive house point of view, as maybe you know, and quite interesting from listening to Lois earlier, which was a bit of an eye-opener to me. We come from the other direction, which was getting 0.35 U value on walls. So we're aiming for NFIT on any particular job, or that's where our mindset has been. And so we've done the thickness of diathonite and other insulations to get that 0.35. So we've used evolution on this job, and then thermoactive on the present job that we're on at the moment. But looking at those graphs, Lewis, earlier, I'm just wondering whether we were mistaken. Interesting enough. And when Jasper talks about pain in his first year using this machine, my God, do I know what he means. It is really, it's an art. It really is tricky, actually. And it's been an uphill struggle, to be quite honest. We've got there and it's a beautiful job, but it's not an easy path. It certainly isn't. So anyway, I'm not going to talk about the rest of this retrofit conversion. Let it be said that it's been great, but this is the way that I look at walls and internal wall insulation. What type of wall is it? What's it made up of? What are the risks? Rising damp, rain-driven damp, interstitial condensation. That's the dew point reach within the wall. People, if you remember back to your physics at school. So we then do, what solution do we come up with? In this case, it's cork and lime, the diet with diatomaceous earth, which is the evolution, and then we check with Woofy. So our first project, so this is 2016. We did it in 2 phases, the barn conversion and then the farmhouse retrofit. Right back to the stonework, obviously. So with the evolution at the 0.45 lambda value, we're talking about 100 mil. That also has the nylon mesh or fiberglass mesh. I'm not sure what it is, Jasper, that putting it in about the 3rd coat. So,
yeah, anything over 50 mil, 60 mil.
Yeah. So this is Jordea from Middlesex. They came up and stayed in the local hotel for several weeks, basically on the 2 phases. And they did a great job, actually, on the whole, apart from not filling in our gap here. Can you see? So we wanted to take all timbers out of the walls because we wanted to take the risk away. Remember, we're west facing right on top of the Pennines. This isn't a brick house in Manchester, actually. So what we thought is that we'd be able to spray down here and just fill it up easily. It wasn't the case. It was too gloopy, or it was, I don't know. Anyway, we found out later, basically, that there wasn't enough sprayed in here. This is on the barn side. We worked out that there was 1.4 square meters of wall plate without the proper air tightness behind, or insulation, come to that. And that is the main reason why we never reached the Enefit air tightness standard of 1. We reached 1.4. We realized what had gone wrong. And so on the second phase in the barn, in the farmhouse, where we actually cut back the existing floor, look, put in this timber wall plate, we hand filled it before Jordair came back to do the rest of it. Can you see here? So that's hand filled from the top. That had a, you know, a temporary piece of timber underneath. This is a product called compact foam that we deal with a lot, which is a structural polystyrene. This means that we can take our strategy all the way through. We've also isolated the steel work into the walls. This is foam glass around our steels so that the steel stays warm. So here we are, look. Most of the, I think there's only 7 of them working, these moisture sensors in the wall. What we're looking for in reality is around 20% WME, wood moisture equivalent. In theory, rotting occurs up here or can occur. Now this is another thing. All the manufacturers, including Diathonite, or suppliers, when they do woofie, will want you to put on a brick cream outside. Brick cream in the sense of it's not what it sounds, it's a clear vapor open solution. We don't do it because traditionally around here, we find that it breaks down over time and the clients don't know when it's breaking down. So we tend to steer away from it. But as you can see, we're coming down to the 20% here. And we're also finding that on our other projects with other methodologies, Tech 10 and the Sturley Barn and so forth, that 20 to 25% is safe, in our opinion. So there we are. That's the barn conversion and the farmhouse above. Are inside, if you can see that. A lovely finish, as Lois's was. It is a beautiful finish. It's hard. It's airtight, and it's as risk-free as we know, capillary and vapor open. So this is the project we're doing now. Form factor is terrible. So because the actual house is this 2-story piece here and this single story. This area is still being left as a barn. It's the farmer's, and this is the way she wants it, which is fine, of course. The customer's always right. But the form factor is terrible. In PHVP, I can't get it down below 55 kilowatt hours per meter squared with the 0.35 U value on the walls. There's the pointing that has been done in the past, probably 20 or 30 years ago, which is traditional around here in Yorkshire with iron, sand and cement. Of course, all that's come out now. We've repointed it with lime. The roofs were in, on the 2-story bit was in a terrible state. We had to take the whole lot off and rebuild the walls up for 6 feet. The single story was a lot better and had been re-roofed within the last 10 years. So that's mainly been left. So here we are, Jasper, and you'll laugh at us here, look. They've used screeds, timber screeds, temporary timber screeds. So on this job, we've gone for the thermoactive, and we've reckoned that that's 85 mil to get to the 0.35 U value. And they're so unsure of themselves at first. They've been using these timber screeds to get enough on there. or to give them security. I think this is a mistake, and hopefully will develop as we go on. And just as Lewis and Jasper has indicated, it is really messy, really, really messy. Here's the G4 machine, okay, that Jasper's, which is great, but it takes a lot of coaxing along at first. Here's
Tuning, Bill.
one.
Tuning.
Here's the three-phase generator. It's a three-phase machine. That makes a bit of noise, I'm afraid. You need at least 3 people, I believe, Jasper. Anyway, you've got to have one out there feeding the machine a lot of the time, and then at least 2 people inside dragging around pipes.
So what I'll just add to that, Bill, you're absolutely right. So what we tend to do for the base coats, the worm coats as we call them, 3 is the minimum. So 1 on the machine, 1 on the gun, and one catching stuff. When we do the top coat, because it's that quick to go on, you need 5. So you need at least a couple of plasterers, at least.
I think that's, well, there are 5, there are 6 in the building team, and they all just pile it. They're multi-traded basically, and we've worked together for the last 25, 30 years. So we just overlap with trades. But I got a lot of earache, I must admit, from them, especially at the first. They're quite pleased now, I might add. So here we are. We've got the top coats on. It's beautiful. But what are the downsides? Cost. It's expensive. We found the coverage that the manufacturer tells us an ecological, and I'm in discussions with Finton, my dear friend Finton, Ilias, up at Ecological. We use far more than I thought we should be using. Extremely rough stonework, right, on these barns. So we fairly soon decided to do a dubbing coat of what was it called? Border lime Duro. We decided to put lime coat, flattening coat on first of all, to try and cut down, which is cheaper. It's about, it's half the price or a third of the price or whatever it is. But even so, I think because they were using screeds and were so frightened of not getting enough on there, they've got too much on, to be quite honest. And the manufacturer talks about up to plus 20% over the coverage, they say. I think we were more like 35%, something like that over. Now, whether that's because we were flattening it too much, Jasper, with our...
I'd say it was, Bill. Over the last 3 years, with Evolution, we tend to be about 110% of the manufacturer. So we tend to use 10% more. Some of that's waste, isn't it?
Yeah, so, yes, it is, yeah.
Yeah. So the only time we would use the screeds, and we have used them, is on slightly more modern buildings that are flat walled, where they want really flat finish.
Right.
Okay. Otherwise, we say to people, it will follow the wall, and unless you want to spend a little bit more money for us to flatten it first.
Okay. Oh, by the way, look, we also look. They actually put in temporary formers for the reveals because we were really intent on getting 85mm right into the windows. That's compact on the side of progression windows. So these are 0.65 U value progression windows. So I'm looking at a pretty good psi value here, enough to I don't, the client won't, but I could certify within the elemental method of certification, which you can do with NFIT. Right, I'm nearly, right. So yesterday we had an air pressure test with our dear friends, Paul Jennings, and I'm very pleased to see that we've got 0.68 air tightness. NFIT is 1. So it works along with all the rest of the building. Of course, it isn't just the diathonite. I'm very pleased, but 90% RH at the moment in there, 90%. we can't start joinery for some time. We haven't got the heating, it's underfloor ground source heat pump yet. Hopefully that's going to go on this week. We worked out there is 13,000 litres in this house. There is 300 square metres of thicker than 85 mil. That is 13 metre cubed of water. That is a lot of water to get out. And you can actually see here the mold growth on the gypsum plasters because it's so humid. And there's just a couple of pretty pictures. Okay, there we are. That's enough for now, Anika.
Brilliant. Thank you so much. That's really interesting and useful insight, particularly from Ben Jasper, as the sort of realities of installing this kind of material. So we do have a few questions that have come up. And for anyone in the audience, if you've got more questions, please get them in the Q&A box. So I think because we're short on time, I'm going to just read the questions rather than asking anyone to speak. I'm sorry about that, but it just goes a bit quicker. So we've got one a question here from Ginny for Jasper. Can you name any non-hydraulic insulated lime plasters? I live with southwest exposure on the edge of Dartmoor.
Non-hydraulic?
Yeah.
Yeah, so the one that Lois mentioned, the Eden Hot Lime Mortar do, which is it's got hemp and perlite in, I think. We've only used it once. So that's non-hydraulic. That's the only one we've come across. We've not come across anything that's as well performing as Diathonite. So I won't. You got to be careful. It's a mixture of things. You know, the Argasem lime plaster that Ecological Cell is a hydraulic lime. So we sometimes use our own non-hydraulic lime skim on top just to balance it out a little bit.
And here's another one. So from Katrina Austin, thank you for great presentation so far. I wondered how you deal with the detailing and particularly the thermal bridge at the corners where the internal and external insulation would or would not meet. I think some of this was brought up in Phil's presentation, but perhaps Bill, Jasper and Lois might have more to say.
So what was the question? How do you deal with thermal?
Thermal bridge at the corners where the internal and external insulation would or would not meet.
Oh, I see. That I think it's more for Alan, isn't it? What happens is that you have to return it, usually. So you usually return the internal wall insulation, quite often to a chimney breast internally. You can't take external round the corner for a metre, then stop it, because it would look pretty silly. So basically you have to overlap and then do a therm model on it.
And yeah, that's usually the way of dealing with that kind of thing, with any kind of insulation, I think.
I was going to say that's exactly what we did on ours, and I modelled it in therm, and yeah, returning it for a metre was sufficient to mitigate that thermal bridge.
Great. So there's a question here from Carla. She said, so I think this is referring to Lewis' presentation. So the splatter coat was the diathonite straight onto brickwork and then lime plaster on top. It's just a question, I think.
Yeah, that's right. So the spatter coat was intended to make a key for the thicker coat to hang on to. So I think, Jasper, you put the spatter coat on in the morning and then perhaps did the worm coat in the afternoon or something like that. I
can't remember, Lois. Were the bricks glazed or were they painted? I can't remember.
They weren't glazed. They had been painted and we'd scraped all the paint off, but they were still shiny bricks. You know, they weren't rough bricks at all.
Yeah. So yeah, that you depending on the temperature outside or inside, you can spatter coat in the morning, and sometimes we put the worm on an hour or two afterwards. It just depends on the wall, on the temperature, on everything. But things like steel. I mean, I think was it steel? I think it was at the front, Lois, wasn't it? Upstairs. You know, was there a beam? I can't remember.
We didn't coat that beam. We didn't coat that beam, but we did do some steel that was an upright next to the front door, and that's worked
and again,
really well.
Spatter coat, a really thin spatter coat just to get a key.
Yeah.
So there's another question here from Lawrence. Thoughts on using lime wash externally to reduce moisture penetration and maximize the beneficial thermal mass? It's open question to any of our experts.
Was that lime wash?
Yeah, so I'll read the question again. Thoughts on using lime wash externally to reduce moisture penetration and maximize beneficial thermal mass?
I don't think it would have any effect on thermal mass.
I'm
Yeah,
not
because
sure.
it's just a wash.
Would it wash off basically through rain?
So our experience with lime wash is it tends to need to be replaced every 4 years, give or take. So, you know, lime. There's a company called Lime Green do a self-coloured lime skim product that we use quite a lot now. Again, you're back into the hydraulic, non-hydraulic type discussions there.
Okay. So Ginny's asked, I'm intrigued by the options of bare plaster finish, i.e. not painted. Obviously aesthetics are personal, but do you feel like the top coat of lime plaster would be appropriate to be left raw?
I love our finish with just the raw lime plaster. I think it's absolutely gorgeous. It's a really soft grey, sort of owing towards a pinky grey. It's lovely. I think the barn I saw at Slaggyford that was one of Jasper's jobs was bare finished as well, wasn't it?
Yeah.
And yeah, that's really nice.
And that was the Argus. I think did you use a lime putty, Lois, and silica sand? I can't remember.
Silica sand.
Lime putty.
It might have been. Tom's in charge of the
I think
lime
it was
mixture.
when I spoke to you. Yeah.
Yeah, let's go with that.
I think Bill used Argus on his presentation, and we've used it. And I think if you it depends how you want it finished. You can be trowel finished or sponge finished. I quite like the natural finish, to be honest, personally.
Well, my 2-year-old granddaughter with a felt pen would soon, and basically wherever she went, and dirty hands. That's what I think. You know, around light switches and things. I don't know how practical it is, really.
Yeah,
I hadn't given any thought to that, but it's worth keeping in mind.
definitely keep that in mind, Lois.
Yeah.
As an update from Lawrence about the lime wash question. So they've said U values fall rapidly with moisture content, hence the question.
Yeah.
Lime wash can be topped with a silicate paint to last longer, smiley face.
So we've planned to, we haven't yet done all of our window reveals where they have been lime plastered, well, lime rendered. We're going to coat them with lime wash with linseed, which I think is a more natural alternative to the brick creams that Bill mentioned. But the one that we have done that hasn't got linseed, so it's just been a lime wash, already looks like it needs recoating, and I think it was probably done only 2 years ago. So it will be an ongoing maintenance job. But yeah, definitely to keep your walls drier will improve the U value.
The Safeguard product, and I've forgotten the name of it, actually, they seem to guarantee, they're saying 25 years guarantee. That's what they're saying. So take that, you know, however you want to, really. You're muted, Anika.
I just realised. So there's a question here from Amma. Is there a possibility of prefab panels of diathonite rather than a spray application?
Yeah.
He didn't say rather than a spray, but I assume that's...
Yeah, wood fibre board, it's called.
Right. And so what are the benefits of installation that has been sprayed onto a wall rather than something like wood board where you're joining lots of bits of insulation together? Why would someone go for a spray application, given how messy it is?
It takes away all the problems of what Lewis was just talking about, which is air pockets behind rigid boards, particularly in rough wall situations. Flattening that stone walls that we've got in these ones, for example, takes, you know, bags and bags of whatever. So in some ways, you might as well just use diathonite as flattening the wall that you would have to for wood fibre board. And by the way, Woofy was showing us on these barn conversions that if we could have used a hybrid of diathonite and then wood fibre board on top, which I think is quite an interesting view, because you're then getting over some of the moisture issues and expense of material, because the wood fibre is actually cheaper than the diathonite. We looked at it, but Woofy was showing us on these conversions that we'd still need 40 millimeters of thermoactive and 60 millimeters wood fibre board to get to the 0.35 U value. And when I spoke to Jude about it, he wanted to just carry on just doing thermoactive and not add another material into the mix. He thought it would just be adding too much work. On reflection, I don't know if he was right. It's out. I would suggest that it's quite a nice compromise in a lower exposed position to think about diathonite and wood fibre.
I'd just add to that on the wood fibre thing. If the wall's quite wonky, when you're putting the adhesive on to make it stick to the wall, if the wall's a little bit off, you might have pockets of air behind the wood fibre that you can't mitigate against. No matter how thick you go, you don't know that they're not there. And I've worked on properties where the walls have been incredibly wonky, and rightly or wrongly, we've ended up on site just putting a ribbon of the adhesive around the board to stop sort of thermal bypass between boards, and that is a bonus that diathonite's got.
Yeah,
I think.
So we don't have any more questions from participants, but I wondered if anyone had any final comments, and whether, Alan, you wanted to say anything as well about sort of your thoughts.
Diathonite's easier to hang shelves on than wood fibre, for example.
Because it's semi-structural? It's not structural.
Yes, it's quite strong.
It's just strong.
Those behind me are hung on wood fibre with no plugs or anything, and they've
We're sort of losing you
hung
here,
on pretty
actually.
well so far. Oh.
Any final comments from anyone else? You look like no. Okay.
Ginny got hand up there. I see.
Oh, thanks for pointing that out, Ginny. Maybe I'll invite you to speak. Ginny.
Hello.
Hello.
Hello. Thank you. Sorry, I'm literally awaiting a quote from a local installer of diathonite for my retrofit, and I'm also going to be training as a retrofit coordinator to work down in Devon with community energy groups. So I'm super interested. And I was wondering, so someone asked, and the question was answered in the Q&A about the Green Homes grant, and I think it was answered that it's not BBA approved. And I just wondered if there were any rumours around whether either it would become BBA approved at any point in the near future, or whether there's any way to get around that at all with the kind of past 2030 installation standards. If anyone knows.
No, I don't know. That would be
I don't know either.
ecological.
Yeah, don't know. Sorry.
That's all right.
Okay,
Email
sorry.
ecological.
Whereabouts in Devon are you?
Just on the edge of Dartmoor.
Okay, yeah. I'm from Devon originally. I moved out at 18. I know.
I was going to just say I had a similar question, which I think actually it was Jonathan Atkinson forwarded me this contact, and also Devon, about a conservation property that they were not allowed to use diathonite on from their conservation officer.
Yeah.
And yeah, the conservation officer was really putting up a lot of barriers to its use, which I think is quite a shame.
Yeah, we'll see if we can work on them.
Yeah, perhaps they just
It's-
need educating.
Well,
Yeah.
I see it's largely the evidence base, isn't it? No one wants to stick their head above the parapet and say that something's right when it's currently a new product. That's the issue.
I think we've got PAS 2035 working in our favour though, because in conservation areas they're classed as protected buildings, so would require someone with a traditional building qualification who's then going to be backing up the idea that it needs to be a breathable system, and diathonite is the most robust from what I found. And certainly that's been reinforced tonight.
Yeah.
Okay, so I'm going to just wrap this up now because we're almost approaching 7:30. Just want to thank all of the panelists for their input. It's been super interesting. There's been lots of comments on the chat about how useful and interesting this has been. And we have recorded it and it will be up on our website. So if you know anyone else who's interested, particularly if you're anyone in the supply chain who's interested in working this further, please do get in touch because we're wondering about supporting this area to grow. In the chat, I've left a link to something called the Jamboard. So this is our way of doing evaluation. I'll just share my screen so everyone can see what it looks like. If you've been on our webinars before, you've probably seen this, but it's just a way for us to capture a little bit about what you thought was good, what you thought wasn't so good, any recommendations you've got for us, and to just rate the session between 1 and 10. So if you don't mind just having a go at that, you sort of click on a sticky note, write something like great content, experienced, see all my typos now, installers, and press save, and then it will pop up on the screen. So if you just have a go at, getting us some feedback, and you can sort of look at what everyone else is doing at the same time, which is quite nice. And let me know if you can't access it and I'll give you access. And I'll just leave it up after the session. So if you need to go and have a comfort break, obviously that's absolutely fine. And then if you don't mind giving us a bit of feedback when you can, that's great. Someone's saying it's view only. I did share it as anyone can edit, so I'm not quite sure what's going on there, but I'll copy the link again. Here we go. So that should work. My apologies if it doesn't. But yeah, that's that. So I'll leave that as a shared screen. Thanks so much again to Bill, Lois, Hurst, and Alan. And yeah, we'll see you next time. So that's all from us for now.
Thank you.
Thank you.
Thanks, everyone.
See ya. Bye.
Odo, are you still there?